Hi everyone, it's Sorkin. Today we have a problem when we are given end-to-end matrix math and we need to return the distance of the nearest zero for each cell. And the distance between two adjacent cells is 1. So let's create one more matrix here where we are going to store the value, the distance for each cell to the other cell with the value of 0, right? So let's create the matrix with the same size. And let's start for the first one. For the first one, what is the value of this cell? The value of this cell is 0, so which means that the distance is 0 because the nearest cell with the value of 0 is the cell itself. So we are storing the value for this cell is 0, and we are storing for all other cells where the value equals to 0, right? How about this cell? So we have solved already for these cells. How about this cell? For the cell with the value of 1, doesn't matter which directions we are going, right? Up, down, left, or right. So we are making only one step, and the distance between two adjacent cells is 1. So it doesn't matter which direction we go, we are making only one step, and the value of the nearest cell is the next cell to the left, right, up, and down is 0. So we are making only one step, and we are storing the value for this cell as 1, and we are returning this output. Let's take this example and work on it. So let's say that we are given this matrix, and what we are going to do, we are going to return the same matrix, and for each cell we are going to update the value. So instead of its value, right, we are going to update the distance from that cell to the nearest cell with the 0. So how we're exactly going to do that? We are going to implement BFS algorithm, and we are going to maintain one more matrix. Let's call it visited, and it's going to be Boolean. So for each cell, if we are visiting that cell, we are going to mark that as a true. For the default, as for beginning, right? So we are setting all these values by default to false. So how we're going to implement our breadth-first search algorithm? So for the breadth-first search algorithm, we are going to maintain a queue, right? In the queue, it's the first in and the first out principle. So we are going to go over our matrix, and for each cell where the value is 0, we are going to mark them. So we are going to add them to the queue, and we are going to mark them as true, and we are not going to visit them again. So why? Because what is the distance for this cell, let's say for this cell, to the nearest cell with the value of 0 is the cell itself. So which means that the cell itself, so which means that we are marking this as 0, and we are visiting. So we are doing the same for all other cells with the value of 0, right? And we are setting those to true in our visited matrix, and we are adding all of them to the queue. So how many of them we have? 5, right? So we are adding all of them to the queue, and now we are taking from our queue one by one and visiting the nearest cells. So for example, for this one, right, let's say for the cell with the value of 0, so for the cell with the first cell, the first one that we have added. So for this cell, so which cells we can visit? We can visit the cell below, and we can visit the cell that is on the right. So we cannot visit those because they are already marked as true, right? So we are going to the next cell. For the next cell again, so which cells we can visit? We can visit the cell that is on the left, that is on the right, and the one that is below. So again, for this cell, for these two cells, right, because we cannot visit because we have already visited them, and we are visiting only this cell. So for this cell, what is the value of the value of the nearest adjacent cell for this one, the cell itself, and we set that value to 0. So 0 plus 1 gives us 1. So which means that the value for this cell, the nearest adjacent cell with the value of 0 is this one. So we are adding 0 plus 1 gives us 1, and we are marking that as also true, and we are adding that to our queue, and we took from this queue the first one, right? We took from our queue the second one. Now we are going to the third one. So for the third one, we can visit only on the one on the left, the one on the below, right? So but both of them are marked as true, and we are just taking that from our queue. How about this one? So this one is so which cells we can visit? We can visit the one on the right again and the one that is below, right? So the one that is on the right we are not visiting because it's already marked as true. The one that is below, so the one that is below, so what is the value of that? The value of that is, so that we are visiting from this cell, right? So we are coming from this cell. So the value of coming to this cell is 0 because this cell itself, the value of this cell is 0. That's why we mark that as a 0. 0 plus 1 gives us 1, and we are marking it as 1, right? And we are setting that to true in our, so we are marking that as a true in our visitor matrix. And let's go to the next one. The next one is this 0, right? For this 0, again, which cells we can visit? We can visit the one on the left, and we have already visited that. We are not visiting it, and we are visiting the one that is below. So again, like the value of coming here is 0 plus 1 is 1, right? So we are marking it as a 1, and we are marking this we are marking in the visited the value to true, right? So we have already visited that. And the next one is which one? The next one is 1, right? So this one that we have added, so we are adding this one, and we are adding this one also, these two ones. So the next one is 1, this one that we have added earlier. So which cells we can visit? We can visit the one on the left, the one on the right, the one on the left, and the one that is below. So again, the value of the distance of coming to this cell, so the nearest cell with the value of 0 is this. We marked it as 1 because we came here from this cell, the one that is above, and that's the nearest cell. So we marked as a 1. So the value of coming to this cell, right? The value of coming to this cell is 1 plus 1 gives us what? Gives us 2, right? Gives us 2. So we are updating this value to 2, and we are marking it as true in our visited array. And the next two ones, and we are adding these two also to our queue. And we are finalizing our BFS algorithm. So we are taking this one from the queue, right? So again, for this one, we have visited all the cells. So we are not visiting any cell. The same we are doing here, and the same we are doing for the last element in our queue. And we are returning this updated matrix. Okay, first thing that we do here, we are checking our matrix. If our matrix is empty or if our column is empty, then in that case, we are just returning the empty matrix. If it's not, so we are taking the length of our rows and how many rows we have and how many columns we have, and then we are creating a queue. So the next one is we are creating a matrix visited, and we are setting all the values for to false by default. And the next step is we are going over our matrix, and what we do, we are checking that if our matrix is equals to, if our cell is equals to 0. If our cell equals to 0, so what it means? It means that the nearest cell with the value of 0, the cell itself, so we are adding that to the queue, and we are setting that in our visited matrix, so we are setting that to true. And the next step is we are creating a list with the directions. So we are going to go left, right, up and down. So for each of those, we are creating set of coordinates for the directions, and then we are going and we are taking from our queue elements one by one. So we are taking from our queue, and we are setting our row and the column, and we are taking our x direction and the y directions, and then we are adding to our new row and the new column. We are adding, so we are basically going to each directions, right? Left, right, up and down. And for each case, we are checking that if our new row and the new column, the first thing that we are checking, it should not go beyond the boundaries of the matrix. So it should be more more than or equal to 0, or it should be for the new row, right? It should be less than the size of the row. The same for the column, it should be more than or equal to the 0 and less than the size of the column. And the next one, we are checking that if we haven't visited that new row and the new column, right? So what we do in that case? In that case, we are setting the value for that new row and the new column, whatever the value of the row and the column is, plus 1. So for example, in case of the 0, right, let's say that we are visiting the nearest element, so that we are, if we take the previous example, we have added 5 zeros, and let's say that we are taking the first 0 and we are visiting the nearest cell with the value of 1 that we haven't visited yet. So the value of our current cell is 0 plus 1, so we are setting for the new row and the new column the value of that to 1, and we are marking it as a true also, so we are not going to visit that cell again, and we are adding that to our queue. Once we finalize this, added all the elements, take all the elements from the queue, so then we have the updated matrix with the nearest cell with the value of 0, and we are returning that matrix. So what's the time and space complexity of this solution? The time complexity is we are visiting each cell only once, so it's rows multiplied by columns, right? And for the space complexity, we are using here we are using matrix visited, and the size of it's going to be also rows multiplied by columns. Okay, the Java implementation is identical. So what we do here, first we are checking the base cases. If our matrix is equals to null, or if the rows and columns is equals to null, then in that case we are just returning matrix. If it's not, then we are taking the size of our columns and the size of our rows and the columns, and we are creating a queue, and we are creating matrix for the visited, right, with the boolean. So, and by default the values for the visited will be set to false. So the next step, what we do, we are going over our matrix and we are checking that if the value is equals to 0. So what it means that the nearest cell with the value of 0 is the cell itself, so we are marking it as a true, and we are adding that to our queue, and those cells will be marked as, so those cells will be marked as 0, and we will not going to visit them again. So the next step is we are creating directions. So we are going to go up and down, left and right. So for those directions, we are creating two-dimensional array with the directions, and then the next step is we are going over our queue. So until our queue is empty, so what we do, we are taking each cell step by step, right? So for the cell, we are taking a row and we are taking the column, and then in the next one we are going for 4 directions, right? We are going for 4 directions. So we are taking the value of new row and the new column, which is the row plus direction 0, which is the x coordinate, let's say, and the direction 1, let's say y coordinate. And for the new row and the column, what we are checking that the first thing that we are checking here, we are checking that whether or not we are going beyond the boundaries of our matrix. If we go, then we should skip that. That case is not valid, right? So new row, if it's more than or equals to 0, or if it's it should be more than or equal to 0, and it should be less than or equal to rows. And the same for the new column should be more than or equals to 0, and it should be less than the columns, right? And that is the first set of conditions. And the next condition is that if we haven't visited that, the new row and the new column, then we are visiting it. If we have already visited, then we are again skipping that. So what we do in our matrix for the new row and the new column, we are updating the value of the row and the column, whatever the value of the row and column we had, plus 1, right? Because let's say that we are coming from the cell with the value of 0, so 0 plus 1 would give us 1, and we are going to update that in the new row and the new column, and we are marking that in the visited. So in the visited matrix, we are updating the value for the new row and the new column to true, and we are adding that to the queue. Once we exit this while loop, which means that in the queue there is no elements and we have visited all the cells, and we are returning our updated matrix. And the same time complexity is we are going to visit every cell only once, so it's rows multiplied by columns. And for the space complexity is we are using one extra space here, which is visited, and the size of it is rows multiplied by columns, so our space complexity is the same as the time complexity, rows multiplied by columns. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.